So let's do one more limiting case here. And so let's see what happens. And let's imagine that we've got a power supply right here, 75 volts RMS, and we have a resistor right here. We have an inductor right there, okay, and let's say the resistor is 710 ohms, and up here we have a resistor and a capacitor, and the capacitor is 240 ohms. And so the question is, what's the current flow at high frequency, and what is the current flow at low frequency? So I want to know the current at high frequency and low frequency. Well, we know that the current is going to be equal to V over Z. Okay, so we got V over Z. All we got to do is find Z. So we need to find the limiting cases of low frequency and high frequency. So at low frequency, then the inductor acts like a wire and the capacitor acts like a break in the circuit. So that means nothing flows through the top path up here. Everything flows through the middle wire there. And so that means that the only thing that the current sees is the 710 ohm resistor. So the impedance goes to 710 ohms. On the other hand, at high frequencies, then the inductor acts like a break in the circuit, and the capacitor acts like a wire, and so the only thing that the current sees is the 240 ohm resistor. Okay, and so that means that we can then say that for low frequencies, then the current, which is going to be V over Z, will be 75 volts RMS divided by the 710 ohms. And so that means it's 0.11 amps. So now for high frequencies, then the current is going to be the voltage over the Z high, so it'll be 75 volts RMS divided by the 240 ohms. And so the current will be equal to 31.2 amps. And again, that really, we should say RMS for both of those. Okay, so it'll be 31.2 amps or 0.11 amps, and so that's going to be the limiting cases here.